Alright, today is October 12th, and we're going to be doing an intro to quadratic functions. So let's go ahead and get started. So with our quadratic functions, we're going to have the parent function y equals x squared, meaning that all of my quadratic functions are going to stem from this one parent function. So it will create a U-shaped curve that we call a parabola. The axis of symmetry is a vertical line that divides the parabola into equal parts. So it's going to cut it right down the middle and make it symmetrical on both sides. And the turning point of the parabola is called the vertex. So if we're graphing that parent function, let's zoom in a little bit, we would have a point right at 0, 0. Let's put 0 here, because 0 squared is still 0. So then 1 squared is 1. 2 squared is not 1 anymore, or not 2 anymore. We're not going to follow that pattern because 2 squared is 4. Then 3 squared is 9. So for our points, we would have 1, 1, 2, 4, and then 3 goes up to 9, which is off the graph. And then the negative of that, negative 1 squared is negative 1 times negative 1, which is going to give me a positive 1. Negative 2 squared is negative 2 times negative 2, which gives me a positive 4. And then negative 3 times negative 3 gives me positive 9. So over here, we would have negative 1 to 1, negative 2 to positive 4. We would connect those and make that U shape, make that parabola. And that's what our parent function is going to look like. It is centered right at the origin with the vertex right there. And then we have our parabola facing up. So with our quadratic functions, the standard form of a quadratic equation is y equals ax squared plus bx plus c, where a, b, and c are just any number. A cannot equal 0 though. So a quadratic equation is going to create that U shape that we talked about called a parabola. So just make sure that A cannot equal 0. So we want to sketch these functions. So we want to graph them first. So let's graph x squared plus 2x minus 5. Excuse me while I type this in real quick. If you have a calculator there, you should be typing away as well, so you can see the graph yourself. Because again, this is just going to be a sketch. So we have that parabola, and it's not going to have the vertex at the origin anymore. Its vertex is going to be somewhere over here. Remember, this is just a sketch. And so our parabola is facing up and does something like that. Remember, it's a sketch, it's not accurate. If I asked you to graph it, then that's different. That's where we want to plot each of those points and make sure that we are getting it correct. If it's a sketch, then just do your best. Make sure your negatives are negative, your positives are positive. So then on the next example, we are graphing, well, we're sketching the graph for negative x squared plus 3x plus 7. So if you have your calculator there, try to bring up that graph, negative x squared plus 3x plus 7, and we see that those graphs don't look the same. They look very different. And the main difference is that one is facing up and one is facing down. So that a value, the first value we have, if it is a positive number, then the parabola will open up. So it's going to look like this. So if a is positive, then we have a happy face. If a is negative, then we're going to be negative with a frowny face. We're going to open down. So remember, a is that first number when we're in standard form. So if a is positive, we're happy. If a is negative, we're going to be negative and we're going to be frowning. So the different parts of the parabola, the vertical line that divides the parabola into two equal parts, we said was called the axis of symmetry. In order to find the axis of symmetry when we're in standard form, is x equals negative b over 2a. The turning point of the parabola we said was called the vertex. So when the vertex is the lowest point, we call that a minimum. When it is the highest point, we call that a maximum. So on our graphs here, the vertex, it's the lowest point. So this is a minimum. On the graph on the right, this is the highest point. So that is a maximum. So we want to determine whether each of these functions has a minimum or a maximum, and then find the axis of symmetry and the vertex. So on number 1, f of x equals 4x squared. My first value, the first number attached to x squared, is a positive 4. If it is a positive 4, then we're going to be happy and open up. If we're opening up, then the vertex is going to be the lowest point, which means I have a minimum. Then we want to find the axis of symmetry. That's x equals negative b over 2a. So x would equal negative 0, because I don't have a plus bx. So there's 0 x's. So 0 over 2 times 4, but 0 over anything is 0. So my axis of symmetry is the line x equals 0. And then for my vertex, we have 4x squared, and my axis of symmetry is at 0. So let's plug in that 0 to my equation. Y equals 4, 0 squared. Anything times 0 is 0. So my vertex would be at 0, 0. Now on number 2, we have negative x squared plus 6x. So my a value is negative 1, b is 6, and c doesn't exist. So if it helps you to write out a, b, and c, I know sometimes it does for me, then go ahead and write a equals, b equals, and c equals, and then get started. So if we have a negative a value, we're not happy about it. So we're frowning. We're going to have a highest point, which is the maximum. Now, in order to find my axis of symmetry, I've got x equals negative b over 2a. So in this case, x would equal negative 6 over 2 times negative 1. 2 times negative 1 is negative 2. So we have negative 6 divided by negative 2, which is a positive 3. So x equals positive 3 is my axis of symmetry. And I know that axis of symmetry is going to cut my parabola straight down the middle, going through the vertex. So if I know my x value for the vertex, then in order to find the y, I just need to plug that in. So y equals negative x squared, so negative 3 squared plus 6 times x, which is 3. 3 squared is 9, so negative 9, since the negative is on the outside. If the negative were on the inside, it would be different. We would have a positive number. So be careful with that. And then plus 6 times 3, which is plus 18. Negative 9 plus 18 is a positive 9. So my x value is 3, my y value is 9. So now on the next page here, we've got 2 more examples. The bell might ring here in a couple of seconds, so just bear with me. Oh, bear with me if the bell starts to ring. So on number 3, we've got f of x equals negative 2x squared plus 7. My a value is negative 2, the one with the x squared. My b should be with an x. None of them are with an x, so b is 0, and c is 7. So to find whether I have a minimum or maximum, I need to look at a. A is negative, so I'm not happy. I am a negative person. And negative means that there's going to be a highest point, so that is a maximum. For the axis of symmetry, we get x equals negative b over 2a. So x equals negative 0 over 2 times negative 2. Since we have a 0 on the top, it's going to end up a 0. 0 divided by anything is 0. So my axis of symmetry is x equals 0. And then I'm going to plug in that 0 to find my vertex, because remember the vertex is a point. So y equals negative 2, 0 squared plus 7. So this first part, because it's multiplying by a 0 squared, which is 0, is going to give me 0. So I get y equals 0 plus 7, so y equals 7. So my vertex, x, y, would be 0, 7. Now number 4, we have x squared minus 8x plus 9. So now we have an a, a b, and a c. My a is 1. So anytime you don't see the number in front, we're going to say that it is 1. Anytime you don't see that variable at all, then it is 0. So since we do have an x squared, we have 1x squared. We have negative 8 for b, and then 9 for c. So my A value is a positive 1. I'm positive, so I'm happy. I'm going to be opening up, which means I have a lowest point and a minimum. So to find my axis of symmetry, I have x equals negative b over 2a. X equals negative 8, which is a positive 8, over 2 times 1. 8 over 2, which is 4. So my axis of symmetry is x equals 4. It's going to be that vertical line. And then my vertex I'm going to get by plugging that 4 back in. So I have 4 squared minus 8 times 4 plus 9. So 4 squared is 16. 8 times 4 is 32. And then plus 9. 16 minus 32 is negative 16. Add 9 to that. We get y equals negative 7. So my vertex is at 4, negative 7. So that lowest point on the parabola would be at 4, negative 7. So this is all standard form. That ax squared plus bx plus c is standard form. There's another form called vertex form that we could use. And vertex form of a quadratic equation looks like y equals a x minus h squared plus k. So I know it looks confusing because we've introduced new variables h and k, but vertex form to me is much easier to use. So when we're using vertex form, I already have my vertex in there. I don't need to solve for it. It's hk. We have to be careful though because this does say minus h. So if we're just looking at the equation, it's going to be the opposite of whatever we see h is. So just be careful with that. And then the axis of symmetry is going to be x equals h because it's going to be that vertical line that cuts it. And this is where my x's are my h. Remember here, my vertex 0 and 0, 4 and 4. So here, x will equal h. It's going to be that x value of the vertex. And then a will determine the width and the direction of the parabola. So just like in standard form, where it determined the direction whether it was up or down, it will still determine whether it is up or down. So why in the world would we want to use this form when we have standard form? Why would we want to introduce new variables? Well, vertex form shows all the transformations. So just looking straight at that equation, I know all the transformations that happen to the parent function y equals x squared. So I don't have to physically graph it and say, okay, it moved to the left, it got wider. I can just look at the equation and know based on the numbers. So it is very useful when we're talking about transformations. So we've got a couple of, we got 3 of them, of equations in vertex form. So we're going to find maximum and minimum, the vertex, axis of symmetry, and then we're going to talk about domain and range. Give me a second. Alright, it should ring again in a second. So here we have, should look like y equals a x minus h squared plus k. My vertex is hk. So on number 1, my vertex, remember it's x minus h, so it's just the value 2 and then 3. Axis of symmetry comes from x equals h. So x equals 2. My a value I don't see, which means a equals 1. If a equals 1, it's positive. Positive graphs will have a minimum value. And then when we're talking about domain and range of these functions, on my parent function, the domain is going to go all the way to the left, all the way to the right. So it's going to cover every single value. My range is going to start at 0 and go up. So we're not going to get any lower than 0. So 0 included all the way to infinity. This is my parent function. So from the parent function, we moved to the right 2 and up 3. My domain is not going to change. I still have this U shape that is going to encompass every single x value. So the domain is still negative infinity to positive infinity. If you need to graph to find the domain and the range, that's absolutely fine. Now for the range, we moved up 3. So my lowest value is no longer 0. My lowest y value is now 3. So my range now goes from 3 to infinity. Now on number 2, we have x squared minus 4. Alright, sorry about that. The tablet did not want to work with me. So we're still on number 2. And if we're looking at this the way that we've got written here, we're looking at it in vertex form. My a value is 1. My h value, nothing's being added onto or subtracted from x. So my h value is 0 and my k value is negative 4. So that's important for our vertex because our vertex is 0, negative 4. My a value is a positive 1. Positive graphs have a minimum. Axis of symmetry is the x value of the vertex. So axis, x value. The domain does not change. Domain does not change. So negative infinity to positive infinity. The range will change. So the range, remember we're facing upwards and our lowest value is negative 4. So if we're looking at that point negative 4 as our lowest point, then we've got to start our range at negative 4. And it will go to infinity since it is facing upward. And on number 3, we're still in vertex form. So my a value is 3. My h value is 4. Remember, it's x minus h, so x minus 4, we just take this number. And then k is 0. I've got nothing adding onto in the back. So a is a positive 3. So this is facing up as well, which means it will have a minimum. My vertex is hk, so 4, 0. Axis of symmetry is the x value of the vertex. Domain does not change. And then for the range, we're looking at that lowest point, which is 4, 0, my y value. That's the lowest y value I can have, which would be 0 to infinity. So if you have to draw out a sketch of what these graphs would look like and find where your vertex would be, like what I've done here, do that. That's going to help you. So whatever helps you to visualize, go ahead and do that. So that's the notes for today. Make sure you check what the assignment is, and then I will see you guys tomorrow in the next video.